I work at WAG, and I'm a data service tech lead. I've been working with databases for over 20 years. I have about 10 years experience with Microsoft SQL. That's where I started. And then after that, I shifted to MySQL. And I've been using MemSQL for the past 2 years. I discovered it about 3.5 years ago, and I've been using it for about 2 years. So WAG is a on-demand dog walking, sitting, and boarding platform. We are often referred as the Uber for dogs, where dog owners can schedule walks for their dog, and dog walker come to the house of the dog owner and walk the dog. We are in 43 states across the United States and about 100 plus cities, and we do more than 1 million walks per year. So I just wanted to show you a little bit about the database technologies that we use at WAG. So on the left side, you have the different data sources that there's more, but this is just a short list of data sources that we pull. Zendesk, Facebook, AdWorks, MailChimp. We use Aluma for the pipelines, and we dump all the data into Snowflake. We use MySQL for the OLTP, and we use MemSQL to leverage MySQL. We also use MemSQL replication for reporting, for near real-time analysis. So when I started to work at WAG about a year ago, I came on board, and they had a big challenge. Their MySQL server CPU was at 90%. And they were using an M4 10X instance, which is a pretty big machine. 40 CPUs, 160 gig of RAM, right? You would think that the MySQL server would fly, but this is what was happening. They had to reboot the server multiple times during the day. So when I came on board, the first thing I did is I tuned the server, right? And that brought down the CPUs to about 45, 50%. But that was not enough, right? Because WAG is growing, and I always like to think ahead, right? I wanted the CPU to be at 20%. This will allow me to reduce the instance size by 2, which would bring the CPU around 40%, right? And still give me some room. So we had a lot of different databases, right, in place, and we were basically spending a lot of money in AWS to serve all the different queries that we had at WAG. So why was this MySQL server not able to handle all the requests? Like I said earlier, I've been using MySQL for 10 years, and I like MySQL. It's a great database, but there are some limitations, right? One of them is the heavy writes that we were doing, which I'll explain in a moment. The aggregate queries that we could not perform efficiently on the replicas, and the MySQL limitation that we had because of the version that we are using. So the heavy writes, so a reflex of a lot of startup companies, right, is to put everything into the same basket. You have a database, it's easy to spin up. You spin up the RDS database, and you start putting everything in, right? So we had table like event type of table, log type table, right, in MySQL, which was basically overloading the system. The tables were growing very quickly. There was a large amount of writes. When you have a large amount of writes on your master database, it creates lags on your replica. If you have lags on your replica, you cannot use your replica for reads, right? Because some queries are sensitive, so there's a delay between your writing into your main database and reading from your replicas. So these are the characteristics of the table that we were looking at, right, to remove from MySQL and move them into MemSQL, right? So growing very fast, so we needed something that allowed fast ingestion, right? Grow very large, so we needed an engine that can compress the data very well, and also being able to use the database, to run some analytical queries. So the replica lag when I started, before transitioning those heavy writes to MemSQL was pretty high, right? So on the left side are the averages, and on the right, the max. The averages went down, quite significantly after we started moving those tables, but there were still some maximum, some pretty high peaks during the day of lags. So that was not enough. We needed to move more, tables into MemSQL to bring down the lag, right? The goal was 0 lag in order to really be able to move as many read queries from the master to the replica, right? So that's very important because a lot of companies, the reflex they have is they're going to increase the size of the server, right? But when you do that, you just, you're postponing the problem, right? Because your data is going to grow, and 6 months from now, you're going to be facing the same issue, right? You're going to be facing the same issue on a bigger system, right? But you still have the core of the problem is still there. It doesn't go away. So after moving the writes, right, those heavy writes to MemSQL, and starting moving all those queries to the replica because the lag went down, the CPU went below 20%. Right? So this allowed us to reduce the size of the instance across the entire RDS stack. We also migrated all the databases that were running on Aurora for the location where we track location of the workers, right? We moved that also in MemSQL. So MemSQL allowed us to pull from different direction, right? Merge all these heavy writes type of table and centralize them on MemSQL. The other issue we had was aggregated queries. As you know, when you start doing counts, sum and group by, right? These become very painful on MySQL because MySQL engine is not built for this type of queries, right? MySQL use InnoDB. This is used for OLTP system, right? It's fast insert. If you read on the primary key, it's going to be very fast. But once you start grouping data, large amount of data, you start to face issues. So there are solutions out there where you can do data partitioning, right? But it's cumbersome, right? You have to set it up, you have to maintain it, you have to monitor it. It's not an easy thing to do. And partitioning is kind of walking on eggs because you need to create your partition so that your new data gets partitioned. You need to remove old partition so that you keep your database size in a proper manner. You can also move partition from one system to another, but you still have to manage those partitions. So it's additional, all this adds up, right? When you have a 250 table into the database and you need to, optimize, it's a lot of work. It's a lot of optimization. And then there's some MySQL limitation. Functions, right? If you have a column that is indexed and you run a function on that index, the index is going to be ignored. So immediately your query is going to be penalized and it's going to scan the table. CTE queries that are very useful are only available in 5.8. Window function are also available in 5.8. So basically, RDS and Aurora don't support this type of query as of now. So we had to move all this data, right, from MySQL, and we're talking about 700 million rows, right? They're not small table. And to move these large amount, right, you need something efficient, right? So fortunately, MemSQL comes with pipelines, right? And the pipelines can plug into S3 and other, like Hadoop and HDFS and file system and Kafka. But the S3 for us, for our needs, was excellent because we could export the data directly from MySQL into S3, right? Locally first and then copy to S3, then load that into MemSQL. So the pipelines are very easy, right? It's basically SQL code. There's no trying to figure out, what kind of settings you need to set up, et cetera. It's very straightforward, right? It's basically these lines. You name it. So this looks like a DDL statement for a table, right? Create the pipeline, give it a name, load data in S3 bucket, so you give the path, your configuration, right? So if you use S3, this is pretty standard, your credential, into table, and then you define the delimitation of the data. And then you start your pipeline, and you're done. And your pipeline runs. So I'd like to show you a little demo. At WAG, we started using weather data because we realized that weather impacts the dogs, right? When it's too hot or when it's too cold, right, it can affect the health of the dog. So we wanted to bring public data, weather data from all across the United States, and the goal is to layer that on top of all our walks and see how the weather impacts the walks. In the near future, we're going to do predictive, right? Being able to use weather in the future and predict our walks and interact with the owner and tell them to reschedule, et cetera, et cetera. So I have some script already prepared, right? So what I did, the first thing is I created what's called a weather data import table, and I basically set everything to be varchar or car. This way I don't have to figure out with the data type at this time. It's easy to import, right? The next code is to basically create your pipeline, right? So the pipeline is already created because I had to enter the S3, right? So the pipeline is here. And the table is empty. So one cool feature that I like also, right, is I can test my pipeline. I run the code. I want to make sure that my pipeline is going to import the data properly, right? So this looks good to me, right? So the next piece is to start the pipeline. So now the pipeline has started. So in the background, MemSQL looks at the S3 buckets and start loading the data into my database. The really cool feature also of this pipeline is if I add new data into the S3 bucket, it's going to be loaded automatically into my table. So for weather, it's perfect. All I have to do is go to the site, download the data, put it into the bucket, done. I don't need to do inserts. It gets loaded into the table. So if I look, so I can look at, right, errors. There's no errors. And then I can look at, oops. Right, all right, so it's in progress. See here, it's still running. Bingo. So now 35 million rows have been loaded into MemSQL, right? So to load 35 million rows in MySQL is going to take you much longer than that, right? I've been using load data in file right before. Load data in file does about 100,000 rows a second. MemSQL is close to 800,000 rows per second, right? So you have to think about the potential here. You can export any data from MySQL, dump into S3, create your pipeline, and then boom. In no time, you have that data from MySQL in MemSQL, and then you can start running queries. So 35 million rows, right? So in 0.05 seconds. Not too bad, right? If you try to run this in MySQL, it's going to take you a while, right? And of course, I can start doing some aggregated queries, right? 0.18 seconds. Not too bad. And I can, of course, start looking at using where clause, right? And we're still running very fast here. And here I want to remember the date was imported as a varchar, so I want to convert the date as a date, and then use the year function on it, right, to bring me years, right? So we're still looking at 35 million rows, right, which is pretty crazy. Now, I want to only bring US weather, right? I'm not interested in the world weather. So I have this query that's basically going to import the different weather type, weather elements, right? There's precipitation, minimum, maximum, and average temperature. And where station code is like US. Oops. Now I'm selecting 35 million rows, right, going through it and doing all this workloads on US and gets inserted in 7 seconds, right? So I can look at so now I'm into data exploration, right? I can look, okay, what are the different elements that exist, right, and the one I can work on. So we have snow, temperature average, not sure what this is, and this might be wind, maybe. And I can do again, here I don't need to use the string to function. I have my date already in place, right? And I can run my count. This is just discovery. I want to see, okay, I want to make sure I have at least 365 days, right, for the station in 2018. Now, I want to take it to the next level because as you can see here, the elements are listed in one column, right? I want to split them into multiple columns, right? So I'll have one column for precipitation, one for temperature, maximum temperature. And I'm going to insert into it, and I'm going to use the pivot function. So it takes a little longer, but it should not be too long. Here you go, 8 seconds, right? And now we brought, right, the table down to 8 million rows because now the data are in columns instead of being rows. And if we look at it, where is it? Where did it go? Oops. Right. So we have our weather and the different, whoops, there you go. Right, so snow, precipitation, max temperature, mean temperature, et cetera, by date and by station code. So now you have the station code, you need to link that to geospatial data, and then you have all your weather across the United States. So when you're done, then you can stop your pipeline, you can drop your pipeline, you can start your pipeline. I mean, there's a lot of things you can do. It's all SQL based, so this means it can be programmed automatically. Now, I was talking about compression earlier because that's important, right? Large amount of data use a lot of disk space. MemSQL can compress up to 80%, or here, 89%, right? The weather data that has 39 million rows, right, is compressed at 89. The event table that we use in our production environment has 943 million rows, right, is compressed at 82%, which consume only 37 gig of data. In MySQL, we were using 150 gig of data space for the space and 150 gig for the indexes. 300 gig of data, right, in a database. So when we moved that table to MemSQL and dropped it, we saved immediately a lot of space. Right? And as you saw, the speed of the queries, that was the reaction of all our customer service, all data analysts. When they started querying MemSQL, they were like, wow, this is really fast, because they were used to query MySQL. They were used to creating that event table, and it would take 1 minute, 2 minutes, right? And now it returns data in seconds, or not even in seconds. And they were wondering if they were doing something wrong with their query, right? So what's next? So that's what just one aspect, right? Why we use MemSQL was to move all those heavy writes, and also to be able to run, an analytical type of queries on these large tables. The next challenge that we have is those replicas I was talking earlier. We use them a lot for what we call our schedule feed, right? We send schedule out to all our workers, for walks, right? And they see those feeds coming on their cell phone, and they pick a schedule, say, I want to do that walk. Well, these queries are very expensive, right? Because they need to look at geolocation data, and they need to look at and join many multiple tables. And this is the consumption of those queries, right? The top 3 queries, if you can see here, they consume the first 3 stacks, right? So we decided to use MemSQL to leverage those geospatial data. So this is the average consumption, right, of 3 replicas or 4 8x. So these are big machines, right? A lot of CPUs, a lot of memory. They're expensive, right? And we need 3 of them, and they use 40%. So what we are going to do is, right now, before we are querying those replica, the next, what we're going to, it's almost in production. We're going to use MemSQL to query the geospatial data and return the list of primary keys, IDs, feed this into MySQL, which is going to query on the primary key. So those queries are going to go from 10, 15 seconds to under a second. So we did some benchmark, right? The blue line represents, before, the amount of time and how it scales, right? It goes from 8 to 16, 32, 64, and 100, 128 concurrent queries, right? So our 128 concurrent query, this is the time in seconds each query takes, right? 300 seconds. The green line is MemSQL, right? As you can see, at 128, we are, I think it was below 8 seconds, right? So there's no comparison. So we should see a drop of about 2/3 of CPU consumption, right, of those machines, which would allow us, again, to reduce, right, lower down, either remove one replica or basically lower the size of those replica. So this was the consumption when running the benchmark. 128 concurrent query, the CPU is on those replica is maxed out, right? And even at 16, which is not that many concurrent queries, the CPU is at 80%. So it's very, very intensive queries. It makes a big difference when you can use another system to leverage, right, geospatial data, return in fraction of a second, and feed that back to MySQL. So the other potential that we have also with MemSQL is to be able to, we use Aluma for our data pipeline, which stream data from MySQL, which gets also stored into S3. Because we can use the pipeline, we can inject data into tables, but you can also inject data into stored procedures, meaning you can transform data on the fly. So I had one challenge was to take the Aluma, when Aluma reads the binary logs from MySQL, it convert them into events in JSON format, which gets stored into S3. So I inject this into MemSQL, and using the stored procedure, I can convert those, parse those JSON formats and store that into a table that is cleaner, right? So there's a lot of potential, right? You can connect to Kafka, you can connect to Hadoop, you can connect to Azure, so it's very broad, right? And being able to ingest data into MemSQL and do those type of queries is very efficient. So why do I like MemSQL? I look at different solutions, right? There's a lot out there. For me, was the attention to detail. I think when you design a product and you pay attention to detail, right, you come up with a great design. Right? It's like the iPhone, right? All the Mac products, they pay a lot of attention to detail, right? Which means you have a great product. You have a great architecture. There's 2 essential DB engines for OLTP and OLAP, right? So you can really run in an OLTP type environment where you have a lot of transactions, right? We also use MemSQL to replace Redis, right? Where we can use memory table to store data, attribute type of tables, right? Preference table for the users, right? These are fairly short, and you can query them very quickly. So we're starting to also move tables that were in Redis into MemSQL because the performance is very good. And on the OLAP side, on the analytical side, when you use the colon engine, you get amazing performance and compression. So that's what I said, we're starting to replace Redis. And it's also built for today's technology, right? So it uses JSON, geospatial data, has a lot of functions that you can use to calculate distance between 2 points, etc. So we're going to use that also at work for the works. And they have excellent support. I mean, we run into an issue which was not MemSQL fault. It was a New Relic. New Relic detected some slowdown and then started issuing explain to all the queries that were going to MySQL, and explain on MemSQL is expensive and started affecting the cluster. But MemSQL jumped on board and really helped us debug this issue, because it was really hard to figure it out because it was New Relic which was injecting the explain into our queries. MemSQL has a great ecosystem, right? So real-time data with Kafka and CDC. You can transform data. You can plug Spark, right, into MemSQL to inject and also pull data. So it's really really a hybrid database that can do a lot, right? Streaming ingestion, memory optimized table, and also disk optimized table. MemSQL also offer a free tier solution, 128 gig of RAM, which allow you to get your hands on it, right, and test it. So for us, that was very useful because we were able to load a large amount of data and pound on it and see and make sure that it can scale. And they are coming up also with a cloud solution. So you can plug anything on it because it's MySQL, right? Use MySQL protocol. For us at WAG, it was very easy for the engineer to switch. I mean, not to switch, but to start using MemSQL, right? It's exactly the same. You connect to MemSQL like you connect to MySQL. That's it. Is there any questions? Oh, everybody quiet. Did I go too fast? No? You guys want to go to the party, I think. Right? All right. Well, in fact, yeah, great question.
Just to make sure I understood correctly, so the stored procedure happens after training into MySQL?
Yes. So when you create the pipeline, you can choose the destination, right? You can load into a table or into a stored procedure. You can also refer to a Python script, if you want, that will transform your data before it actually goes into the stored procedure or the table. So the Python script gets loaded into MemSQL, and then whatever data you give it, it will gets passed into the Python script. Then after, so for enrichment, right, for example, if you have web logs that has IP addresses, you have a Python script that can do geolocalization, right, to convert your IP into location. You inject that, it will detect the IP, convert it, then it gets injected into MemSQL. And the store procedure allows you to basically, as the events are coming through, you can store them into multiple tables. You can do a lot of transformation. All right. Yes? Mm-hmm.
So they do some kind of in-memory caching for optimizing queries. How do they work with a lot of data that's coming in at the same time you're reading out? How do they?
Well, so MemSQL is a cluster, right? So that means it has nodes, and it has leaf nodes where that's the sharding, right? So earlier I was talking about sharding data. So when you create a table, right, it will shard your data automatically for you. You define a sharding key, and then data gets spread, right? So that's your scalability at the data level, because you can add as many leaf as you want, right? You can have 2, or you can have 100, right? If you have a large amount of data, you can spread all that data across all those nodes, right? Then you have the aggregator. The aggregator are the query traffic controller, right? As the query comes through, it goes, oops, it gets the data on the leaf and then return it back, right? So you can also add additional aggregators as more queries are coming through. So that's your concurrent queries scalability, right? When you load data into MemSQL, and you create your pipeline, it uses the leaf to load all that data, right? So the more leaf you have, then it distributes the load, the faster it's going to go. Right? So yeah, it's really impressive. Yes?
Who is your main competitor? MySQL?
Where did you what?
Redis or MySQL? Who is your competitor?
Well, we use MySQL mostly for the OLTP because that's where the database was built on.
Do you compete?
Well, we don't really compete. I mean, we use Redis, right? Because at the time they didn't know about MemSQL. So when I came in and started scaling MySQL with MemSQL, right? They saw the benefit. They saw how fast MemSQL was. And then the application architect started creating attribute table in MemSQL because he's using the memory engine because he saw how fast it was and that we didn't need to have, Redis, right? You don't need to expire things, you just query those tables. And the memory can handle large amount of transaction, update, insert, delete, right? The column store are more oriented for, inserting data, right, and querying on this large amount of data.
A little more on how what aspects of Redis are the ones that MemSQL was able to take over?
Well, right now we haven't completely converted, but I think there's a lot of potential to use Redis less, and it might stay. I mean, I don't have all the detail because, our stack is pretty complicated. We have APIs and stuff. I was focusing on the, scaling MySQL, and I know that they started also creating those memory tables for attributes, which store JSON string in it, and we just query that, right? So it's a great potential. All right, awesome. Well, thank you for coming.